Welcome to Penrose Learning, where we make understanding easy.
You start by confirming your device and toolchain. Make sure the Apple Neural Engine is available on the target chip, and Xcode is updated. This matters because hardware acceleration depends on both. Once done, enable Core ML and Metal Performance shaders in your project so data moves efficiently to the ANE. Next, convert or export models to ML model format. Make sure to specify precision and compute units. This first step gets the pipeline ready, so inference can use dedicated neural cores. You now focus on adapting your model for the ANE. Convert to Core ML, then apply quantization and pruning to reduce memory and compute. This lowers latency without sacrificing required accuracy. Once converted, set model configuration for compute units to prefer the Apple Neural Engine and tune input shapes and batch sizes to match on-device memory constraints. Then, run real benchmarks on the device, measure latency and throughput, and iterate. Make sure to profile hotspots so the ANE, CPU, and you finish by integrating the optimized ML model into your app using VN Core ML request or the ML model prediction APIs so requests dispatch to the ANE. Once integrated, monitor performance with instruments and the Core ML profiler. This reveals memory spikes or thread contention. If something fails, check for unsupported model operations. Those force a CPU fallback. Make sure to provide graceful fallbacks and log device compute unit decisions. One key troubleshooting tip: update model ops or replace unsupported layers to restore ANE acceleration quickly.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.